Assalamu alaikum wa rahmatullah. Today we are going to perform lab 3 for power electronics and drive. It's about chopper. Class A chopper is a single chopper working on the positive quadrant in the plane. For that we are going for chopping we are going to use IGBT, which is fully controlled. Now if the chopper is on, we know that the power is transferred from the source to the load, and when it is off, the current will circulate through the freewheeling diode. So to perform this experiment we need few equipments in lab vault. The equipments are the power supply. For that we are going to use, for the input of the IGBT, variable DC power supply from 0 to 240. We are going to use this knob to change it or vary it to 150, and it will be fixed through the experiment 150 volt. We also need the data acquisition connected to the computer, and we need also to supply it with 24 volt. We're going to use one ammeter to see the load current and 2 voltmeter for the voltage, source voltage and the load voltage. So the chopper, we are going to use IGBT for chopping. This IGBT, these are the input which are connected to the source, our source, the variable, and we are going to use one output since it is single quadrant. These two switches, we'll just keep them off. The IGBT, as you can see, is protected for overheat, over voltage and over current. This will trip if there is any problem. Also we need to supply it with 24 volt supply, and since it is fully controlled we need to activate the gate of the IGBT by sending a signal. So we need a switching control, and for that one we are going to use chopper and inverter control unit. Now in this unit we have two sources for control. First source here, we are going to connect it to point 1. We can control the duty cycle of the IGBT, the switching. For the duty cycle, the source 2 here, we are going to connect it to point 2 for control, and we are going to use this one to control the frequency of chopping, how speed or how fast we are chopping. For the mode, we're going to select, using this select switch, BWM, and this is the output control, the output where we are going to connect it to the IGBT. For the load, we are going to use resistive load, single phase, and it will be fixed 1200 ohm. This one will. So for the smoothing inductors, now we have these two inductors. We can connect them in series or in parallel. So if we connect in series, that is connect 0.2 to 0.3, then the total inductance will be 3.2 Henry, and then connect 0.1 to the resistor and 0.4 to the negative of the source. If we also connect them in parallel, that is connect 0.1 to 0.3 and 0.2 to 0.4, and then this one connected to the resistance, this is to the source, then the total inductance will be 0.8. So these are the two values for the inductance we are going to use in this experiment. Initially we start with 0.8 for different frequencies, and then we connect them in series 3.2 Henry also for different frequencies. So now if you adjust the frequency to 150 of frequency, and the inductors are connected in parallel, so it is 0.8 Henry, this will be the result we got. This is for the voltage. Now the duty cycle is full using that knob, but you can see it is not 100%. Now you may need to figure out what is the duty cycle, since you know what is the input voltage and what is the output voltage. From there you can find out the duty cycle, or even T on over T off That will be the duty cycle. Anyway, the output current, this is the mean value for the output current, and this is the shape of the output current. And you can see that we have a minimum value and a maximum value that you need to figure out from here. And of course the scale is 0.05 amp divergence, so each centi is 0.05. Using that one, and from the figure here, you can find out what is the minimum current and what is the maximum current. Don't forget that this one is for frequency equal 150 hertz, and the inductor equal to 0.8. Now if we change the duty cycle to 50%, this is 50% duty cycle, this will be shape of the current. You can see now the minimum and maximum value change. So also you need to figure out what is the minimum value and what is the maximum value for the current. These are the mean values for the voltage and current. The same scale, of course. Now if we change the frequency to 500, the same connection for the inductor, 0.8 Henry, but only we change the frequency to 500, then we get this results, 500 hertz. This is for full duty cycle again, is not 100 again, it's 0.9 something. And from there, this is the shape of the current. From this one also you can find out what is the minimum and what is the maximum current. And for the average reading, these are the average reading for that one. So this is 500 hertz and full duty cycle. Now for 50% duty cycle, the same 500 hertz, but 50% duty cycle, this will be the shape of the current, minimum and maximum. And these are the average values for voltage and current. Let's now change the connection for the inductors, connect them in series. We know if we connect the inductors in series, the value will be 3.2 Henry. Now 3.2 Henry, if we reduce again the frequency to 150, so 150 hertz, and the inductor 3.2 Henry, connect them in series, then we'll have different result there. So also this is the full duty cycle, and this is for current, minimum and maximum current we can use, and this is the average values. And for 50% duty cycle, this will be the output, minimum, maximum, the same scale, and the average. If we change now the frequency to 500, we keep the inductor 3.2, connect them in series. So for 500, this will be the shape for the current. You also, from this one, you can figure out what is the minimum and maximum value and the average values. And for 50, this is for 100 for full duty cycle. Now for 50% duty cycle, this will be the shape, also 500 hertz and 3.2 Henry. The two inductors are connected in series. So these are the results for you. If we change the frequency, we use two frequencies, 150 hertz, 4 results we got for two different inductors, and in each value of the inductor we have two duty cycles, 90 something, 90x, you have to find out what is this x, and the 50%. And also for 500 hertz we have also 4 figures, 2 for 0.8 Henry when the two are connected in parallel, and when they are connected in series, 3.2 Henry, and for different duty cycle, 90x and 50. So we have the result for the mean values of current and voltage, and then from the figure you can find out what will be the minimum and the maximum value for that. Thank you very much. Stay safe, stay home.